Biconditional logical operator. The biconditional logical operator is represented with the symbol a double-sided arrow, or sometimes the simple English word if and only if can also be used to represent the biconditional logical operator. Now let's look at the definition of biconditional logical operator. Let P, Q be two propositions. The proposition P if and only if Q is denoted by P biconditional Q is called a biconditional statement. Now, let's first understand the meaning of the statement P if and only if Q. This particular statement can be broken into two statements. The first statement is P if Q, and the second statement is P only if Q. The statement P if Q can be represented as if Q then P, and the statement P only if Q can be represented as if P then Q. This part is the difficult part to understand. If you take few examples, then you will be able to understand this very easily. P only if Q can actually be represented as if P then Q. Now, the statement if Q then P can be formally represented as Q implies P. The word and can be represented with the caret symbol, something that looks like an inverted V. Then the statement if P then Q can be formally represented as P implies Q. Now these two statements can be combined as P biconditional Q. So P biconditional Q means P implies Q and Q implies P. P conditional Q and Q conditional P. Now let's try to understand the different ways to represent P biconditional Q. First way is P if and only if Q. Second way is if P then Q and conversely. And the third representation is P is necessary and sufficient for Q to be true and the vice versa, which means Q is also necessary and sufficient for P to be true. Now let's look at an example to understand P biconditional Q. Consider the following two propositions. Proposition P, I will eat lunch. Proposition Q, I am hungry. Now let's write all possible biconditional statements for the above two propositions. I will eat lunch if and only if I am hungry. The truth value of this first statement is true, and the truth value of the second statement is true. Then P biconditional Q's truth value will be true. I will not eat lunch if and only if I am not hungry. The truth value of this first statement is false, and the truth value of this second statement is also false. That's why the value of P biconditional Q will be true. I will not eat lunch if and only if I am hungry. The truth value of this first statement is false, and the truth value of this second statement is true, and the final truth value will be false. I will eat lunch if and only if I am not hungry. The truth value of this first statement is true, and the truth value of the second statement is false, and the final truth value will be false. I definitely believe that different possible combinations of these two given propositions P and Q will help us to understand the meaning of the statement P biconditional Q. Now let's look at the truth table of P biconditional Q. P, Q, P biconditional Q. If P is true, Q is true, then P biconditional Q will be true. If P is true, Q is false, then P biconditional Q will be false. If P is false and Q is true, then P biconditional Q will be false. If P is false, Q is false, then P biconditional Q will be true. In this table, you can observe these two rows. P biconditional Q is true only when both P and Q have the same truth value. In every other case, P biconditional Q will be false. That's why we say P is necessary and sufficient for Q to be true, and similarly, Q is necessary and sufficient for P to be true.